Hello and welcome to my video on conversions. I'm going to do a couple of examples of unit conversions, which you're probably going to be doing a lot, especially in physics, so get used to it. Make a warm, comfy place for it in your heart. First of all, well, I'll just go ahead and jump into the examples. So we're going to convert 55 miles per hour to meters per second. And I've already got my note here of 1 mile is equal to about almost 1,610 meters, 1,609 meters. So we can do these with equations sometimes, or just through multiplication, and the second method I'll demonstrate is more of a chemistry conversion way. So here we go. So 55 miles per hour, so 55 miles times, again, 1 mile is equal to 1,609 meters, so we're going to multiply it. And I'm not worrying about my sig figs today, so okay, and this gives us about 88,000 and some odd change meters. Okay, so there's my distance conversion, my time conversion. So for 1 hour, in 1 hour there are 60 minutes. Again, I'll multiply. And in every minute there are 60 seconds. So 60 times 60 is 3,600. You'll probably get pretty used to that number eventually. So taking our meters per second, that'll give us about 24.6 meters per second. Okay, so that's the sort of multiplication method. And now I'm going to switch it up here and do the chemistry conversion way, which is my favorite way to do it. It's what I'm most comfy with personally. So, and this way involves crossing out units. That was kind of messy. That was supposed to be parentheses. Alright, so I'll go ahead and do my time first. So in every hour there are 60 minutes. Again, in every minute there are 60 seconds. Okay, so the point of arranging it like this is to keep straight what I have to multiply and what I divide. So I put my units, I want 1 in the numerator and then 1 in the denominator, so my hours cancel out there. Minutes over minutes will cancel out as well. So right now I'm at miles per second, so I need to convert my distance units. Okay, so again, 1 mile is equal to 9.34 meters. That's 1 mile. Okay, so now my miles are canceled out. So that will leave me with meters per second. Okay, so I multiply all of my top numbers, 55 times 1,609.34, divided by 3,600, divided by 60 twice. And again, that gives us 24.6 meters per second. I prefer using this method because it helps me keep track of what I need to multiply as opposed to divide. Okay, here I need to multiply 1609, and these I would need to divide. I kept that straight up here just by sort of keeping my distance and my time units separately and then putting them together, the distance over the time for my velocity. Okay, so next example is more of a problem-solving example, which I will show and demonstrate how to solve this in a couple of different ways. In fact, I'll just use a different color for one. Okay, so there's an equation way to solve this. First of all, you'll notice, especially when you get to the rotational circular motion chapters in physics, that a lot of the equations really just are kind of formulas for conversions, really. So V is for linear velocity, whereas omega stands for rotational velocity, or also 2 pi times the frequency, which I'll also write out a little bit later. Okay, so you'll figure this out very quickly that this is actually sort of there's a hidden conversion going on in here. Okay, so my ball or wheel or sphere or what have you is 1.6 meters is its radius. If it rolls 8 meters forward in 2 seconds, what is its rotations per minute? So first of all, known information, things I know. My radius is 1.6 meters. So I know from this that my circumference is going to be 2 pi times 1.6. Okay, I also know 8 meters in 2 seconds. Now this is a linear velocity if it's rolling without slipping. My ball, it rolls forward this way, so it travels 8 meters in 2 seconds, which means that its linear velocity, if I take 8 and divide it by 2, is 4 meters per second. So that's my linear velocity already. Okay, so we'll see what the circumference is for later. But for now, we'll use this. Okay, so rotations per minute are the units for frequency. Frequency is often written as seconds inverted, like 1/seconds, where this 1 actually represents cycles or rotations or revolutions per second. That's your frequency. So again, I mentioned earlier that omega is equal to 2 pi times frequency. Okay, so my known information, I've got linear velocity and I've got a radius here. So I already see that I can solve for omega. Omega is going to be v divided by r. I also know that omega is equal to 2 pi times the frequency. And since the frequency is actually what I'm looking for, I'm going to want to manipulate these equations. So I'm going to take this here, pretty much go right on past omega and kind of forget about it at this point. And I'm going to solve for frequency. So frequency is going to be equal to the velocity divided by 2 pi times the radius, or velocity divided by circumference. Alright, so if I plug in these numbers, let's see. That's going to give me, again, we already solved this. This is 4 meters per second. And my circumference, I didn't solve this part already, but 2 times 3.14 times 1.6 is roughly equal to 10 meters. So 4 divided by 10 gives me 0.4. Again, this is going to be cycles per second. Now, I want it in rotations per minute. Rotations and cycles are synonymous here. They mean pretty much the same thing. So what I'll have to do is at least get seconds to minutes. So 0.4 cycles per second. I'm going to want to multiply this by 60 seconds to convert it to minutes. Okay, and 60 times 0.4 gives me 24. So 24 rotations or cycles per minute. Okay, so that's an equation-y way to solve this. Now, different color. I'm going to do this the chemistry way. So here we go. If it's moving forward 8 meters per 2 seconds, and again I could have written this as 4/1 instead. I want to convert it to rotations per minute. So time is easy to do, so we'll go ahead and do that. So in 1 minute there's 60 seconds. Okay, my seconds cancel. Alright, now I'm in meters per minute. Not quite what I need. So now here's the fun part. 1 revolution or 1 rotation is how long in its distance. So how long is this? It is in fact the circumference of the wheel, which is 10 meters, right? So 2 pi r, or 10 meters. Alright, so my meters cancel out. And now I'm down to rotations per minute. So again, 8 divided by 2 is 4. 4 divided by 10 is 0.4 times 60. So this will come out the same as before. 24 RPM. Okay, so that's all for this video. If you have any questions or comments, please leave one. And thanks for watching.